All right, we are ready to compare our rational numbers. So in order to compare them, what we really want to do is we want to convert them to both be the same thing. So either both fractions or both decimals. Almost always decimals are going to be easier. Every once in a while, if they're two fractions that are really easy to compare, really easy to change into fractions, that might be easier. But in general, we pretty much always go with decimals. So for this, we are going to change our 1/8 into a decimal. So remember, we are going to put top dog in the house. So over here to the side, I'm just going to show my work. 1 inside, because that's my top dog, and my 8 outside. And I can't take 8 out of 1, so I do that 0 times. Remember, then we can add our decimal, don't forget to bring it up, and add a 0. So now 8 comes out of 10 one time, minus 8. I get 2 left over. I can add another 0 and bring it down. So 8 goes into 20 2 times. 2 times 8 is 16. I have 4 left over, so I'm still not done. Bring down another 0. And 8 goes out of 40. 5 times 8 is 40. So finally, I am all done. So now I'm going to go back to my original problem, and I have 0.125, or 125 thousandths, compared to 0.2, or 2 tenths. And the best way that we've found to compare these is to kind of line them up by their decimal. So I'm going to do that over here to the side again. So if I have 0.125 and 0.2, and I'm just going to add some placeholder zeros here so they kind of match each other. Now I'm going to look like one column at a time and see which one is bigger. So when I look here at this first column, they're both zeros. They're the same, so I have to go over to the next place value. Okay, so the next place value is a 1 and a 2. When I compare those, I know that 2 is bigger than 1, so I know that my 0.2 is also going to be bigger than my 0.125. So if this is greater than, then back in my original problem, 1/8 is less than 0.2. All right, let's go on to the next problem. And we're going to start here again by converting so that they are both decimals. To do that, let's go ahead and put the top dog in the house. So 5 is going to go inside, and our 8 is going to go outside. So 8 can't come out of 5, so we're having a 0 there. Add your decimal and add another 0. 8 can come out of 50. It can come out 6 times, because 6 times 8 is 48. We get 2 left over, bring down another 0. 8 comes out of 20 2 times. 2 times 8 gives us 16, which leaves us 4 left over. We can add another 0 and bring it down. And now 8 comes out of 40 5 times, because 5 times 8 is 40. Okay, now that we're all done, we're going to bring that decimal over here and go ahead and compare it to our other decimal. So we have 0.625 compared to 0.63. And we said before that it's easier, if you can't tell just by looking at them, it's easier to line them up by the decimal place and just compare them one digit at a time. Okay, so I'm going to look here. The zeros are the same, so I move to the next digit. 6s are the same, so I go to the next digit. Here we are, the 3 is larger. So I know that in my decimals, that is bigger. So in my original problem, 5/8 is less than 0.63. Let's go ahead and do the third problem now. And again, I'm going to take this fraction and I am going to simplify it and make it into a decimal. So top dog in the house again. I'm going to ignore the absolute values and the negative signs for now. After we find our decimal, then I'll go ahead and deal with those. So first, let's put our top dog in the house, 11 inside, and our 5 outside. 5 does not go into 1, but it does actually go into 11 this time. So 5 goes into 11 2 times, which is 10. Leaves me 1 left over. I'm not going to use a remainder. I want a decimal, so I'm going to go ahead and add my decimal and my 0 and bring that down. So now 5 goes into 10 2 times again, which is 10. Okay, so I really get 2.2 being equal to 11/5. So I do have these absolute value bars and I have some negative signs and stuff, so let's go ahead and see if we can figure out how to deal with those. I'm going to write my decimal in place of the 11/5, and then we can figure out what to do with all those symbols. So we have the opposite of the absolute value of negative 2.2. Okay, so with this, we want to first do this absolute value bar. So the absolute value of negative 2.2 is positive 2.2. And then I have the opposite of that 2.2, which brings it back to a negative. So really I'm comparing negative 2.2 to negative 2.08. Okay, again, I'm going to line these up just so that we can compare them a little easier. So if I put 2.2 and 2.08, I'm lining them up by their decimal place again, putting that 0 placeholder so I can compare them a little easier. And let's compare one digit at a time. So the 2's match up. So I go to the next number. I have a 0 and a 2. 2 is definitely larger than 0, but the only trick we have here is that we have these negative signs out here in front of each of these. So remember that negatives are basically like opposite world. They both say the opposite. So when we say that this 2 is larger, when we're looking at negatives, that means this 2 is actually smaller. So we're going to have to remember that when we put our sign back in here. So if 2.2 is actually smaller, then the 2.08 is larger, then we're going to have a less than symbol. So the opposite of the absolute value of negative 11/5 is less than the negative 2.08. All right, so let's go ahead and look at the next one. So our negative 2/3, let's change our 2/3 into a decimal. Again, top dog in the house, so 2 divided by 3. 3 cannot come out of 2, so 0 times. I'm going to add my decimal and my 0. 3 comes out of 20 6 times. 6 times 3 is 18. Leaves me 2 left over. I'm going to add a 0, bring down my 0. 3 comes out of 20 6 times again. I can already start to see that I'm going to have a pattern happening here. I'm getting 20, 20. If I subtract my 18, I'm going to end with a 2, bring down another 0, and get 20 again. So already, without doing any more work, I can see that this is going to be a repeating 6. If you didn't notice yet, that's okay. Keep going until you finally recognize, oh, there's a pattern happening. This is repeating. Okay, so now when I bring it back over here, I have negative 0.6 repeated compared to negative 0.666. And just like before, let's line these up to compare them. So I have 0.6 repeated, 0.666. And I've been saying all along, let's keep some placeholder numbers in here so that we can compare every digit. The only difference is here, it's a repeating 6. So my missing digit that's happening right here is not a 0, it's a 6, since this is repeating 6s on forever. So I'm going to put a 6 in here. My other placeholder, another 6. Okay, so now let's compare them. My 0s are the same. 6 is the same. 6 is the same. 6 is the same. So I need to go another digit out. I don't have anything here, so let's put some more placeholders in there. For our bottom number, that was the end of it. That 666, that was the end. So the next number would be a 0. But for our repeating 6, that 6 is going to go on forever, so I'm going to put a placeholder 6 there instead, since this whole thing is repeating. Okay, so now when I compare this last digit, I can see the 6 is bigger than the 0. But don't let it fool you, they are both negative. So remember, it's like opposite world. So if I think that the 6 repeated is larger, well, in opposite world, it's really smaller. So negative 2/3 is less than negative 0.666. All right, I'm going to go ahead and ask you to pause the video, and why don't you try the last 3 problems on your own, and then come back to me, and I will go through the problems on here whenever you are ready. Go ahead and pause now. right, hopefully you got all three of those problems done, so I'm just going to run through them super fast. So for this one, my 3 2/5, I know it's going to be 3 and something, whatever 2/5 is a decimal. So I know it's going to be 3 point something. So I'm just going to top dog in the house, 2 divided by 5. I can't do that, so I move over a spot. 5 goes into 20 4 times, and that works out perfectly. So 0.4, so it's 3.4. And then over here, I have this absolute value sign, so let's make that positive. Remember, the absolute value of 3.35 is still 3.35. It's not the same as an opposite. It makes it positive. See my little smiley face there? It makes it into a positive number. Okay, now I can compare those. So let's line them up, 3.4 and 3.35. And put my placeholder there. And let's compare. So the 3's match up. The 4 and the 3, 4 is definitely larger than 3. So I can go back to my original problem and say that 3 2/5 is greater than the absolute value of 3.35. All right, and here is another problem. So 2.3 is already a decimal. Let's change that 7/3 into a decimal as well. So top dog in the house, 7 inside, 3 outside. 3 does go into 7 2 times, okay, which is 6. I get 1 left over. We're not using remainders though, so add your decimal and your 0. 3 goes into 10 3 times, because 3 times 3 is 9. 1 left over, bring down my 0. I can already see right here I'm getting a pattern. There's a 10, there's a 10. I'm going to keep doing that and getting 10 over and over, which tells me that this 3 is repeating. So I got 2.3 and then 2.3 repeated. So when I line those up to compare them, 2.3, 2.3 repeated, I can already see the 2's match, the 3's match, so I need to go one more place value out so that I can compare them better. So for my top number, 2.3, that was the end, so the next number would be a 0. But for my bottom number, remember this is repeated, so it's going to be another 3 after that. Okay, so now I'm in this column, my hundredths column, and I can see that 3 is larger than 0. So in my original problem, 2.3 is going to be less than 7/3. All right, last comparing problem. So we want to change this 1/6 into a decimal. Top dog in the house, 1 divided by 6. 6 does not go out of 1, so my 0, add my decimal and my 0. 6 comes out of 10 once, which is 6. 4 left over, bring down my 0. 6 comes out of 46 times, because 6 times 6 is 36. 4 left over, bring down another 0. And right here I can already see I'm starting to have this pattern of getting 40 over and over again, which tells me that this 6 is going to be repeated. Be careful this time because the 1's not being repeated. That was when we were going into 10. But now that we're going into this 40, that's where we're getting the 6. So that's the only piece of this that's going to repeat. So it's really going to be like 0.1666666 on forever. Okay, so now when I bring that back over to here to my original problem, I've got the absolute value of negative 0.16, and we'll deal with those absolute value bars now. So the absolute value of negative 0.16, remember that makes this a positive, so when I do this absolute value bar, it's making it positive 0.16 compared to positive 0.17. And if you can't already tell which one is larger, then go ahead and line them up. 0.16, line up your decimals, 0.17, and I can see the 0's match, the 1's match, but here the 7 is larger than the 6. So in my original problem, the 7 is larger than the 6. So the absolute value of negative 1/6 is less than 0.17.